this lecture we are going to see how to select attributes in CART model. In our previous lectures we have seen how to choose attributes by using gain value. In this lecture there are another two methods for choosing the attributes. One is gain ratio, another one is Gini index. In this lecture we are going to see other two criteria for choosing the attributes. First we will look at the gain ratio. The information gain measure is biased towards test with many outcomes. That is, it prefers to select attributes having a large number of values. For example, consider an attribute that acts as a unique identifier such as product ID. A split on product ID would result in a large number of partitions, as many as their values, each one containing just one tuple. Because each partition is pure, the information required to classify data set D based on this partitioning would be info product ID will be 0, because there is going to be only one value in each partition. So, information gain is, we know the formula for information gain is info D minus info product ID for D, because this value is going to be 0. So, the information gain will be maximum. Therefore, the information gained by partitioning on this attribute is maximal. Clearly, such partitioning is useless for classification, because there is going to be one element in each partition. So, the gain ratio is an extension to information gain which attempts to overcome this bias. Let us see what is split information. It applies a kind of normalization to information gain using a split information value defined analogously with info D. So, how to find out the split info for level A for D is minus summation j equal to 1 to V, V is different levels, dj divided by D multiplied by log dj divided by D to the base 2. Here the dj is the single partition. The next slide I have an example, I will explain what is the dj. The D is data set. So, this value, that is a split info, represents the potential information generated by splitting the training data set D into V partisans corresponding to the V outcomes of the test on attribute A. So, let us see what is the formula for the gain ratio. The gain ratio differs from information gain, which measures the information with respect to classification that is acquired based on the same partitioning. So, the gain ratio is gain of A divided by split info of A. The attribute with the maximum gain ratio is selected for splitting the attribute. I have an example, with that I can explain how to use this gain ratio for choosing the attribute. Look at this example. This in my previous lecture also I was showing this data set. Consider in our previous example for computation of gain ratio for the attribute income. So, we are going to take this variable first. We are going to find out gain ratio. I am going to say the procedure for only one attribute. Like that you have to try for age attribute, for student attribute, for credit rating attributes. So, whichever is high, that variable should be chosen for classification. A test on income splits the data into the following table into 3 partitions. See, when you look at this income column, there are 3 levels there. One is low, medium and high. Containing, in low there are 6 elements is there. In medium there is a 4 is there. You see low 6 is there, 1, 2, 3, 4. In low there are 4. This is 4. In low there is 4, 1, 2, 3, 4. In medium this is 6. So, 1, 2, 3, 4, 5, 6. In high there is a 4, 1, 2, 3 and so 4. This example is taken from this book Data Mining Concepts and Techniques and compare. Now, let us calculate the entropy for level low. In level low, how many have answered yes to buy a computer? When it is low, there is a 1, then there is 2, this is 3. So, that is we got 3. So, how many people are answered no when the level is low? Yes, it is only 1. So, the entropy is minus 3 by 4 log 3 by 4 to the base 2 minus 1 by 4 log 1 by 4 to the base 2. For finding the information gain for the attribute income, first we need to know the entropy for the class D. We know that how to find out the entropy for the class D. It is minus Py log Py to the base 2 minus Pn log Pn to the base 2. So, the Py is in our class, how many people have answered yes? When you look at the table, there was a 9 yes and there is a 5 no. So, for yes it is minus 9 by 14 log 9 by 14 to the base 2 minus no. There will be, when you look at here, there is a, look at this one 1, 2, 3, 4, 5, there is a 5 no. So, it is a 5 no. So, 5 by 14 log 5 by 14 to the base 2 equal to 0.940 bits. Now, let us find out the information gain for the attribute income. What is the meaning is, if you use income as an attribute for the classification, how much information you can gain. So, the expected information needed to classify a tuple in D if the tuples are partitioned according to income is, so info for attribute income is 4 divided by 14. How we got this 4 for the income, attribute income? There was a 3 level is there. One is low, medium and high. In low there was a 4, in medium there was a 6, in high there was a 4 values. So, it is a kind of a weighted attributes, because it is nothing but expected information needed. So, it is nothing but our weighted entropy. So, the weighted entropy is 0.911 bits. So, the gain of income is info D minus info for the attribute income. So, we got this 0.94 which we got from this value 0.94 minus 0.911 equal to 0.029. Now, we will go for split ratio. So, the split ratio for the attribute is equal to minus 4 by 14. What is the 4? Because this 4 by 14 multiplied by log 4 by 14 base 2 minus 6 by 14, because this 6 by 14 log 6 by 14 to the base 2 minus 4 by 14, this value 4. So, 4 by 14 log 4 by 14 to the base 2. So, split info is 0.926. Therefore, the gain ratio for the attribute income is 0.029, which we got from this value 0.029 divided by 0.926, that value is 0.031. Further, we calculate the same for rest of 3 criteria, 3 attributes. What are the other 3 attributes? Age is there, student is there, credit rating is there. The one with the maximum gain ratio value will result in maximum reduction in impurity of the tuples in D, and it is returned as the splitting criterion. So, what do we have to do? We have seen for one attribute, that is income. There are another 3 attributes such as age, student and credit rating. For these attributes also we have to find out the information gain ratio. That corresponding attribute should be taken as the splitting criterion. We have found the gain ratio for the attribute income. The same way, there are other attributes like age, student, credit rating. For these attributes also we have to find out the gain ratio. One with the maximum gain ratio value will result in maximum reduction in impurity of the tuples in D, and it is returned as the splitting criterion. For example, assume that the attribute age is having maximum gain ratio. So, that variable should be chosen as the splitting variable. Then from there, if there is a student, assume that the attribute age is having highest gain ratio. So, that age is taken as the splitting variable. Then there is a student, there are remaining other variables, for example, student, credit rating and so on. So, out of these again you have to find out the gain ratio. So, out of this which one is giving the maximum gain ratio, that should be taken as the splitting criterion. Next we will go to another criterion for choosing the attributes, that is Gini index. Let us take the introduction of decision tree using Gini index. Let D be the training data of the following table. So, this table also, this example also taken from the book Data Mining Concept and Techniques, the source is given here. Now, we are going to see how to find out the Gini index. In this example, each attribute is discrete valued because all are in different category. So, continuous valued attributes have been generalized. We did not take continuous value. The class label attributes by computer has two distinct values. This one, when you go back, the class value, there are two distinct values, one is yes or no. Therefore, there are two distinct classes. So, m equal to 2. Let class C1 correspond to yes and class C2 correspond to no. There are 9 tuples of class yes and 5 tuples of class no. A root node n is created for the tuples in D. Now, we will go for calculation of Gini index. We first use the following equation for Gini index to compute the impurity of D. So, the first we will find out the Gini of class D is 1 minus summation I equal to 1 to m. M is number of levels, pi square. So, what is the p? How many s is there? So, 1 minus, there is a 9 s is there, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 14 whole square minus how many no is there? Next level, 1, 2, 3, 4, 5. So, 5. So, the Gini of class D equal to 1 minus 9 by 14 whole square minus 5 by 14 whole square, that is 0.459. Let us calculate Gini index. Previously found the Gini index for income attribute. To find the splitting criterion for the tuples in D, we need to compute Gini index for each attribute. In this, we have taken example income. Let us start with the attributes income and consider each of the possible splitting subsets. Income has 3 possible values, namely low, medium, high. The possible subsets are, that itself is a subset, low, medium, high. Then all possible combinations, low and medium, low and high, medium and high. Then values which is having only one value in the set, low, medium, high and null set. Power set and empty set will not be used for splitting. What is the power set? Where all the element is there. For example, low, medium, high is the power set. The null set is nothing but the empty set. So, this will not be used for splitting. Now, we are going to split into two categories. One is subset low and medium. So, because it is a binary classification, when you go for low and medium, the another group, suppose there are two groups there, group 1, group 2. In group 1, we have taken low and medium. Obviously, the another set will be high. So, this would result in 10 tuples in partition D1. We have to count how many low medium is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, that is why we got 10 tuples in partition D1. So, this group is D1, satisfying the conditions income in the set low and medium. The remaining 4 tuples of D, that is a high, the remaining is high, 1, 2, 3, 4. So, the remaining 4, that is D2. The remaining 4 tuples of D would be assigned to partition D2. So, what has happened? We made a 2 subset, one is low medium, the remaining one is high. For low and medium, for the class variable Bayes computer, we are going to see how many S is there. So, by looking at together the level medium and low, there are 7 S is there, there are 3 no is there. For high, because that was group D1, this is for group D2. For high, how many S is there? 1, 2. How many no is there? There are 2 no's there. So, 2 S is there, 2 no is there. Gini index for income attribute, the Gini index value computed based on this partitioning is Gini income in the set low and medium. So, 10 divided by 14 Gini D1 plus 4 divided by 14 Gini D2. So, how we got this 4? By looking at the low and medium, there are 10 values there out of 14. So, 10 by 14. The another set, the remaining is 4. In D2 there is only 4 divided by 14. So, Gini D we have seen in the previous class, in the previous lecture, 1 minus 7 by 10 whole square minus 3 by 10 whole square. How we got this 7? You see that there are 7 yes, there are 3 no. That is why it is 7 by 10 whole square minus 3 by 10 whole square. For D2 there are 2 yes, there are 2 no. So, 4 divided by 14, 1 minus 2 by 4 whole square minus 2 by 4 whole square. So, this value is 0.443. So, this is Gini value for the income high. For example, if we found the Gini value for low and medium, that is equivalent to finding the Gini value for the next group, that is a high. Consider the next subset, that is high and medium. When we look at the high and medium, there will be 10 tuples 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in partitioning D1. So, here also we are going for 2 group, one group is D1, another group is D2. Here high and medium is in one set, that is in D1. So, when you go for high and medium, obviously the next will be low, the low will be in the set D2. The high and medium, there will be 10 tuples satisfying the condition, remaining the 4 tuples of D would see assigned to partitioning D2. When you look at high and medium together, there is a not 4, 6 yes for buying computer, for 4 no for buying computer. Then the next group, that are tuples in partition D2, for low there is a 1 person has answered no, there is a 3 people are answered yes for buys a computer. Now we will find out Gini index value computed based on this partitioning. Gini index for income attribute, the Gini index value computed based on the partitioning Gini is for income. We have had 2 category, one is D1 and D2. In D1 we had high and medium, in D2 we had low. Now for high and medium, let us find out the Gini index, because there was a 10 out of 14 that comes high and medium. So, the Gini for D1 plus 4, in this low there was a 4 out of 14. So, Gini for D2. So, what is the value of D1? Because in D1, that means for high and medium together there was a 6 S was there. How there is a 6 S? You see that there is 6 S was there. There was a 4 no was there. That is for D1, that is the Gini index value. For D2, the Gini index value is 4 divided by 14. There was a 1 yes is there, there was a 3 no was there. See that? No, there was a 3 s is there, there was 1 no was there. So, 1 divided by 4 whole square minus 3 divided by 4 whole square. So, the Gini index for high and medium group is, it is 0.45. That is nothing but the Gini index for the other group also, that is our group low. Now, we will go to for another subset, that is a high and low. Now, here what you are going to do, we are going to have 2 groups, because it is a binary classification. So, high, low is one group, this is D1. So, the another D2 is obviously it is medium. So, here for this one, this would result, there is 8 tuples in partition in D1 satisfying the income is high and low. The remaining 6 tuples of D would be assigned to partitioning D2. Then high and low, there was a 5 yes is there. For high and low, there was a 3 no is there. Another group is D2, in that there is a medium. In that medium, there was a 2 no, there was a 4 yes. Now, we will find out Gini index value computed based on this partitioning, that is for this group high and low. In high and low, totally there was 8 value, 8 divided by 14. In that 1 minus, there was a 5 yes out of 8. So, 5 divided by 8 whole square minus there are 3 no, 3 divided by 8 whole square, plus for group D2 that is in medium, that was another group, in that there was a 6 element was there out of 14, 6 divided by 14, 1 minus how many s was there? There was a 2 no was there, there is a 2 divided by 6 whole square minus there was a 4 s is there, 4 divided by 6 whole square. So, the Gini index for the group high and low, that is equivalent to for the medium group Gini index value, that also 0.458. We have completed all possible binary classifications. So, Gini income high and low, the Gini index value is 0.458. The Gini for another group high and medium, there is a 0.45. For medium low, the Gini index value is 0.443. How to interpret this table? So, this value 0.443, this is having the minimum Gini index value. Interpretation: the best binary split for attribute income is on medium and low, otherwise high, because it minimizes the Gini index. When you look at the previous table, you look at this, the medium and low, it is having the minimum Gini index value. The splitting subset medium and low therefore gives the minimum Gini index for attribute income. So, the reduction in impurity is 0.459. This value which we got from our slide number 18, this is for the class D, minus the 0.443 we got from this value, Gini index value for each subset. So, the difference is 0.016. Further, we calculate the same for rest of 3 criteria. So, we got reduction in impurity for this is income. There are another 3 attributes, that is age, student and credit rating. For each attributes, we have to find out the reduction in impurity. The one with the minimum Gini index value will result in maximum reduction in impurity of the tuples in D and is returned as the splitting criterion. Now, how to have the classifications? For example, we have income is the splitting variable. There was a 2 binary split. The first one was low and medium is one group, high is another group. Now, in the high also you may have some other table like this. For each value we have to find out the Gini index. For low and medium group also there will be another table. For this value also we have to find out the Gini index. After find out the Gini index, whichever is having highest value of reduction impurity, otherwise lowest value of Gini index value should be chosen as the splitting criteria for further classification. In this lecture, I have explained how to choose an attribute for the CART model by using 2 criteria. One is the gain ratio and Gini index. For both the method, I have taken a numerical example. With the help of numerical example, I have explained how to choose an attribute. In the next lecture, we are going to use Python for making a CART model. Thank you very much.